In this video, we'll be talking about solving a percent mixture problem using a system of linear equations. The problem reads, a scientist has two solutions, which she has labeled solution A and solution B. Each contains salt. She knows that solution A is 45% salt and solution B is 65% salt. She wants to obtain 160 ounces of a mixture that is 60% salt. How many ounces of each solution should she use? So what we're trying to do here is to find the amount of each solution that must be used to make up the mixture. We'll let X equal to the amount of solution A and let Y equal to the amount of solution B. We'll use a table to organize our information. So we'll have our first column with our labels. Then we'll have the next column with the information for solution A. We said we would let X equal to the amount of the solution. We know from our problem that we had a percentage of salt for solution A, which was 45%. And then we know for solution B, we let Y equal to the amount of the solution. And for the percentage of salt in solution B was 65%. For our mixture, we had a total amount of solution of 160 ounces. The percentage of salt in the mixture is 60%. And we get the amount of salt by multiplying down the column. 160 times 60%, we convert that to a decimal, which is 0.60, multiply and get 96. For our solution A, we need to convert the 45% to a decimal, which is 0.45, and then we multiply down the column again to get 0.45 times X. For Y, our percent salt was 65%, we need to convert that to a decimal to give us 0.65. Multiply down the column and we get 0.65Y. Now we can set up our two equations since we've completed our chart. If X is for solution A is added to Y, which was for solution B, and we know our total was 160 ounces, X plus Y is going to give us 160. Then for our second equation, we also add across the row. We had our 0.45X plus 0.65Y is equal to 96. So now we have our two equations that make up our system, so we can go ahead and solve the problem like a regular systems of linear equations problem. We have our two equations. We want to try to eliminate one of the variables. So let's just choose X. So remember, when we add the two equations together, the X values have to cancel out. So we have 0.45X for our second equation. So if we multiply the top equation by a negative 0.45, when we add our two equations, we'll get the x's to cancel out. So remember, we have to multiply the 0.45 times everything in the equation. So we'll have a negative 0.45 times x, negative 0.45 times y, and we have negative 0.45 times 160. Multiplying that out, we'll get a negative 0.45x minus 0.45y is equal to a negative 72. Now we can add our two equations together. The x's will cancel out, and then we have negative 0.45y plus 0.65y gives us a positive 0.20y, and negative 72 plus 96 gives us 24. Dividing both sides of the equation by 0.20, we end up with y is equal to 120. Now that we know what y is, we can plug that back into either of the equations to find x. I just chose the first equation, x plus y equals to 160. So we'll have x, we know that we found our y to equal to 120, equals 160. So subtract 120 from both sides and we get x is equal to 40. So our solution is going to be x is equal to 40 and y is equal to 120.